इसको विंडो अलग कर दी मैंने ताकि हमें शेयर करना आसान रहेगा ना। स्क्रीन करनी
Sir, can we start now, sir?
तुम तो कह रहे थे कि 5 मिनट बाद शुरू करेंगे, अभी करें? Shall we start now or wait for some more time? Because
Sir, we need 5 minutes more.
okay. So, dear participants, welcome to you all. We will just wait for 5 more minutes and then we will start. We are just, waiting for more participants to join. So let's say we'll start at 3:15. Okay, 15 minutes. 15 minutes past 3, we will start the webinar. Thank you.
लीजिए मैंने आया
రేపు తెలవాలా
Sir, can we start now? We have 152 participants, sir.
Okay, okay. Okay. Okay, my name is Shailesh Agrawal. I am Executive Director, BMTPC. At the outset, I would like to welcome all of you. I am so delighted to see participants in such a large number. We are touching 150, and it corroborates the fact that all of us are quite interested in, learning about the new construction systems, new technologies, and implement them. Before I start, let me just welcome you all. So good afternoon and very warm greetings to one and all in this webinar series being held at Lighthouse Project sites. I welcome you all on behalf of Ministry of Housing and Urban Affairs, Government of India, on behalf of BMTPC, GIZ, and on my personal behalf. I also greet and welcome Mr. Gautam, Director HFA5, Shri Sunil Parekh of PMU, and Shri Vikas Ranjan, Director Climate Smart Buildings, GIZ. They are also the co-host of this webinar alongside BMTPC. It's my pleasant duty to welcome other officials also from the ministry, PMU team, GIZ team stationed at various LHP sites. The dignitaries, engineers, officers from state government of MP, SLNA, Indore Municipal Corporation are also welcome, including SLTC, CLTC teams, engineers and architects of other state level agencies. I also welcome representatives of Messrs KPR, which is executing the project in Indore, and also Messrs Rising Japan, the technology providers for this project, and their entire technical team who are executing the project at the site. At last but not the least, I also welcome my dear Technograhis who have registered in such a large number through online enrollment drive initiated by HFA Directorate and participating in all the webinars enthusiastically. We have now more than 34,000 Technograhis, and you Technograhis are basically the change agents to bring technology transition in the construction sector. In addition, we also have engineers, architects, planners, professionals, faculty members, developers, technology providers, and students from engineering and architecture colleges of different parts of India. So we warmly welcome to all of you in this webinar series. Today is the 8th webinar, which is being held at Indore LHP site. We have already completed first round of webinars at all the 6 LHP sites, and now this is the second round. In the first round, we have given you brief exposure to the 54 innovative latest technologies, proven technologies shortlisted through Global Housing Technology Challenge, promoted within the country. And after that, we made a presentation, very exhaustive technical presentation on specific technologies being used in those LHP, specific LHP sites where these webinars are being held. In case you have missed those webinars, there is nothing to worry. All these presentations along with recordings can be accessed through GSTC India.gov.in website. Always remember this website. This is a very useful resource, for getting information about Lighthouse projects, the technologies, and the technical literature on all these technologies. Today, we will also, we will get further insight because we have already conducted one webinar at LHP site Indore. So today, we will try to give you further deeper insights into the technology, its implementation through a virtual tour, and if possible, we will try to show you actual installation of panels, their assembly, installation, and other aspects related with online on-site works. Even though it is being repeated time and again, but for the benefit of all of you, let me again inform you that at present, to showcase these innovative construction systems, 6 lighthouse projects are being implemented in 6 places, namely Rajkot, Chennai, Indore, Lucknow, Ranchi, and Agartala. All these 6 lighthouse projects, 6 distinct innovative technologies are being used, and we are holding these webinars at all the 6 places for participants to get exposure and opportunity to learn all these systems. In addition to that, the Ministry of Housing and Urban Affairs, in association with GIZ, are also organizing physical training programs called Rachna. Rachna stands for Resilient, Affordable, Comfortable Housing Through National Action. So these physical training programs, Rachna, are organized not only at all these 6 LHP sites, but also in different parts of the country for educating the stakeholders about innovations and about the functional aspects of these technologies, such as thermal comfort, affordability, resilience, sustainability, green intervention. So you all are also welcome to attend these Rachna programs. Since these Rachna programs are physical programs, whenever it happens near to your city, you are more than welcome to join these Rachna program. I will request Vikas to just give the address in the chat box, so that if they want interested in joining Rachna program, they can approach you or write an email to you. Let me also tell you here that these lighthouse projects are being projected as live laboratories, which means learning. Live laboratory means learning the different aspects of design, construction during the course of implementation of projects. Through large scale participation of people like you. So while we construct these projects, while we implement these technologies, our aim is to make everyone understand the various nuances of these technologies. So that is why we are calling them live laboratories. And to make it live laboratories, a whole set of activities are being planned at LHP sites, including, as I told you, webinars, webcasting is being done. So again, through the GSTC website, you can get access to the webcasting, and you can get the live feed of all the projects, what's happening at the site, and the click of people. We are also organizing physical training, site visits, and interaction. We have also developed a e-knowledge pack for Technograhis, which is in self-learning mode. And once you complete that knowledge pack, you will be given a certificate. That pack, e-knowledge pack for Technograhis, is also available on GSTC website. Let me also tell you that for professionals, if you are engineers, architects, and want to have deeper knowledge on these technologies, want to learn about the design and other aspects of these technologies, the BMTPC, in association with School of Planning and Architecture, New Delhi, is running a paid e-certificate course on innovative construction system. That course is called Navriti, where for 8 days, 3 hours each day, detailed lectures and presentations are being made by experts from academia, industry, and research institutions, followed by interactive session. So the 10th batch of the course will be starting next Friday, that is 27th May 2022. And if you are interested, you can just go to BMTPC website or Ministry's website or GSTC website and register yourself for the Navriti course. So dear participants, my idea to tell you all these things is that by running so many programs concurrently, Government of India is offering all of us a unique opportunity to learn the field level application of innovative construction systems in real time and build capacities so that these systems can be further adapted, suiting to our requirements and geoclimatic profile, and replicated in our future construction activities. Let me also tell you, use of these innovative construction systems is quite relevant and apt and pertinent in today's context, as globally we are committed to bring resource efficiency, energy efficiency, environment friendliness, disaster resilience, and still, and take our country towards sustainable and inclusive development. Also, you all know that we are rapidly urbanizing. So to keep urban aspirations, we need to fast track construction of buildings and infrastructure. And these technologies which we are discussing with you in these webinars are, they not only impart speed to the construction activity, but also deliver superior affordable housing and infrastructure, which is better in terms of structural and functional performance, quality, durability than the conventional cast in situ RCD frame construction. Let me also share, I'm so happy to share with you that I just talked about the speed. One of the lighthouse projects which we have done at Chennai, comprising of 1001, 1152 tenements in 6-story configuration using precast concrete construction system has already been completed in a time of 12 months, and it will be handed over to the beneficiaries by Honorable PM sometime next week. So one of the project of these LHP project which we are discussing with you is already completed and will be handed over to the beneficiary. So you can, this completion of project despite of COVID restrictions and all corroborates the very fact that these innovative construction systems reduce the construction time by 50% and offer much superior, affordable and quality homes. The on-ground completion of the project is also testimony to the efficacy, to the effectiveness of these innovative construction systems with regard to speed, quality, and other host of structural and functional parameters. You all are most welcome to join that program and visit the project and see with your own eyes the project at Chennai. So far, 7 webinars have been organized at these 6 LHP sites: Rajkot, Indore, Lucknow, Ranchi, Agartala, Chennai. In totality, we will have around 40 webinars till November 2021. And during these webinars, as I told you earlier, also we'll be taking you to a virtual tour to take stock of construction activities and give you hands-on experience on the construction technologies and processes being used. So friends, it's a unique opportunity. So please make full use of this opportunity. And I sincerely hope that you all will be benefited by this webinar and learn new methods of construction, which will help you in your future projects. So once again, I welcome you all. And before we start a general lecture, giving you overview of all 54 technologies which were shortlisted under GSTC.
Hello.
I will request Sunil and Vikas if they can run a 5-minute film on LHP.
Sorry, sir. Unmute.
Thank you very much, sir. We will just starting the video as well.
Ministry of Housing and Urban Affairs, Government of India, has initiated Global Housing Technology Challenge India to identify and mainstream best available global technologies, so to bring paradigm shift in the construction sector. 54 innovative technologies put in 6 broad categories were shortlisted during the challenge process. 6 lighthouse projects at 6 locations with 6 distinct technologies are being constructed. Lighthouse project using prefabricated sandwich panel system with 1024 dwelling units in S+8 configurations, along with all basic and social infrastructure facilities, is being constructed in Indore in partnership with State Government of Madhya Pradesh. Honorable Prime Minister laid the foundation stone of 6 lighthouse projects, including at Indore on 1st January 2021.
आज गरीबों के लिए, मध्यम वर्ग के लिए, घर बनाने के लिए नई टेक्नोलॉजी देश को मिल रही है। ये 6 लाइट हाउस प्रोजेक्ट देश में हाउसिंग कंस्ट्रक्शन को नई दिशा दिखाएंगे। इंदौर में जो बन रहे हैं वो उनमें ईंट और गारे की दीवारें नहीं होगी, बल्कि प्री फैब्रिकेटेड सैंडविच पैनल सिस्टम इसमें इस्तेमाल होगा।
Lighthouse Project Indore is progressing well, and this video highlights the state.
Your connection has gone, Vikas. Vikas, video is not coming now.
टाइप करके जो दिखेगा दीदी टाइप
टाइप कर दीजिए, दे दीजिए मैम, टाइप दीजिए, आप कंटिन्यू।
Vikas, your video is not coming.
It will be restarted, sir, because somebody has shared their screen. So that's the reason there is some.
Chalo karo. Yeah.
So
Okay.
we'll start again.
Ministry of Housing and Urban Affairs, Government of India, has initiated Global Housing Technology Challenge India to identify and mainstream best available global technologies so as to bring paradigm shift in the construction sector. 54 innovative technologies put in 6 broad categories were shortlisted during the challenge process. 6 lighthouse projects at 6 locations with 6 distinct technologies are being constructed. Lighthouse project using prefabricated sandwich panel system with 1024 dwelling units in S+8 configurations, along with all basic and social infrastructure facilities, is being constructed at Indore in partnership with State Government of Madhya Pradesh. Honorable Prime Minister laid the foundation stone of 6 lighthouse projects, including at Indore on 1st January 2021.
आज गरीबों के लिए, मध्यम वर्ग के लिए, घर बनाने के लिए नई टेक्नोलॉजी देश को मिल रही है। ये 6 लाइट हाउस प्रोजेक्ट देश में हाउसिंग कंस्ट्रक्शन को नई दिशा दिखाएंगे। इंदौर में जो घर बन रहे हैं वो उनमें ईंट और गारे की दीवारें नहीं होगी, बल्कि प्री फैब्रिकेटेड सैंडविच पैनल सिस्टम इसमें इस्तेमाल होगा।
Lighthouse Project Indore is progressing well, and this video highlights the status of the project. In this system, the panels are manufactured at the factory in controlled conditions. Sandwich panels made out of cement or calcium silicate boards and cement mortars with EPS granules balls act as wall panels. These wall panels replace conventional brick masonry and can be used as load-bearing as well as non-load-bearing walls. The panel having tongue and groove are joined together for making the wall. These panels can be used both in RCC and steel frame structure. In Indore, the steel frame structure is being used. Construction of Lighthouse Project Indore was started with excavation of site, followed by laying of plain cement concrete, footing work, erection of stem column as per foundation design, construction of plinth beam, and backfilling to complete the substructure. While foundation works were going on for all towers, the prefabricated steel components as well as sandwich panels were made ready in factory. Superstructure work started in all 8 towers sequentially, involving assembly of column, beams, placement of deck sheets, reinforcement including fixing of electrical and plumbing services. Concreting of 40 out of 72 slabs have been completed. As the installation of steel structure progressed in different towers, EPS sandwich panels are also being fixed from lower to upper floor. Superstructure framework reached up to 6 floors in 4 towers and 4 floors in other 4 towers. Simultaneously, infrastructure work of drainage, sewerage, underground water tank, erection of compound walls, community center, solid waste management plant, electrical substation, etc. are also going on in full swing. A sample flat with all amenities is ready in Tower 3 for showcasing it to the beneficiaries and other stakeholders. The LHP Indore is serving as live laboratory for learning and dissemination of knowledge. About 350 Technograhis and other stakeholders have visited the site to learn the use of innovative technology in real project at site.
Thank you. Thank you, Vikas. So, this was about, it was a short film on Lighthouse Project at Indore. And now I will, through a presentation, I will, make you understand about the 54 innovative construction systems, which we have shortlisted through Global Housing Technology Challenge and promoting them across the country. But before that, I was just telling you about the Lighthouse project which we have recently completed in Chennai. I just received a 30-minute video of Lighthouse project at Chennai. I will just show you that. So let me just share my screen. This is the Lighthouse project in Chennai, which is completed in March 2022, and just next week it will be handed over to when we release. The technology used here is precast construction system, which means all the structural elements, precast components, they are manufactured in the casting yard, which is near to the site, and then later transported and erected at the site. So I just wanted to show you the efficacy that, see, already this project is completed and being handed over to the beneficiaries in a short span of 12 months. And it is 1,152 beneficiaries. So with this, let me just go to my first lecture. Let me share this screen with you, and I will ask Vikas if you are able to hear me. Kevin, we can.
Yes, sir, yes, sir, we can hear you, sir.
Share?
Yeah.
Yeah, are you able to share? Are you able to see my screen?
Yes, we can, sir.
Yeah. So this is the webinar series number, it's number 8th webinar, and we are at the Lighthouse Project site Indore. So first lecture is on emerging construction system for mass housing. Essentially, I will be telling you in a very simple language about the 6 broad categories and 54 construction systems which we have shortlisted. But before that, because the entire GS Global Housing Technology Challenge India is being conducted, organized, and these lighthouse projects under Pradhan Mantri Awas Yojana, and Pradhan Mantri Awas Yojana has been a huge success. Out of validated demand of 1.12 crore houses, already 1.213 crore houses have been sanctioned, and near to 1 crore houses have already been grounded, and around 6 million houses have already been completed and delivered to beneficiaries. So this is one of the largest, housing program ever taken in, across the globe. So we should all feel proud about the success of this Pradhan Mantri Awas Yojana. And under this Pradhan Mantri Awas Yojana only, we were running technology submission, and under technology submission, this Global Housing Technology Challenge was conducted, and now Lighthouse projects and technology promotion. Also, through this Pradhan Mantri Awas Yojana, we would be able to create, several crores jobs, direct and indirect. As you can see in this slide, 213 crore, person days employment was generated directly through, Pradhan Mantri Awas Yojana urban projects, and indirect employment was of the tune of 475, which is equivalent to 76 lakh direct, and 170 lakh means more than around 2.5 crore jobs were created due to Pradhan Mantri Awas Yojana. Also, the bottom portion of this slide gives you the steel and cement consumption. You can see the cement consumption is by the end of this, when all the houses are completed, it will be 75 million tons, and steel will be 17 million tons. So with this, that was about the Pradhan Mantri Awas Yojana statistics. I told you that we organized Global Housing Technology Challenge, which was organized by Honorable Prime Minister, and the website, which is written at the bottom of this slide. Please do note down this website. This is a This is one of its kind website where you get information, about everything about innovative technologies in form of technical literature, from the, in the form of leaflets, brochures, certificates, testimonials, audiovisual capsules, presentations. So we have tried to create a database, the resource base for all these innovative technologies at one place, and that one place is this website. So you can just visit this website and get access to all this information, which will not be available otherwise. Through this Global Housing Technology Challenge, 54 new construction systems were, shortlisted, which are divided into 6 broad categories. And just for the sake of clarity, we divided them into 6 broad categories, and gave them these names, which are written here. I will try to explain you these 6 broad categories one by one. So one is 3D volumetric precast concrete construction. Other one is 2D, precast concrete construction system. The third is light gauge and steel. And the fourth one is sandwich panel system, which is also known as drywall construction. Fifth category is monolithic concrete construction, and most of you might be aware of my1 system. So that is called monolithic concrete construction or aluminum formwork system. And last category is the stay in place formwork system. So under each category, you can see 4, 8, 16, 9, and 9 and 8 technology providers were shortlisted. So in totality, we have now 54 the innovative technologies available with us. So we always say that we have created a basket of 54 new technologies, depending upon your requirement, depending upon your geoclimatic conditions. You can choose any one of them and use it. Then, to further propagate these technologies and for further propagation of these technologies, as I was telling you in my inaugural lecture, we initiated the Lighthouse Projects, where at 6 places, these 6 broad categories are being showcased through actual construction of 1,000+ houses along with basic infrastructure facilities. And we are conducting webinars, physical training, on-site interaction, and host of other activities to bring technology transition in the sector. So these Lighthouse Projects, the GSTC was organized in 2019, then the tender was floated, and finally the Lighthouse Projects were awarded, and the foundation for all these 6 Lighthouse Projects were laid by Honorable Prime Minister virtually in the August presence of all the CMs of honorable CMs of all these states on 1st January 2021. And this is March 22, and most of these projects are at advanced stage of completion. And as I showed you in the video, already one project in Chennai is completed and being handed over next week to the beneficiaries. The question which will be coming to your mind, that I have been talking about innovative construction systems. So what is that innovative construction system, and what do we have with us? So let me first tell you what we have, the construction systems which are popular, prevalent, or omnipresent or ubiquitous across the globe are these 2 systems. One is brick by brick, or it is in civil engineering parlance it is called load bearing structure, where you construct or create walls, load bearing walls by brick and mortar or by stone and mortar, and over these load bearing walls you cast a slab, which is essentially a reinforced concrete slab cast in situ slab. So this is a typical construction when you are dealing with isolated houses, or you are dealing with low rise single story or 2-story houses. So that is the most prevalent system in tier 3 cities, small cities, villages and all. So it is called brick masonry or load bearing construction. But now this system has also been replaced by RCD frame construction, which is seen here on the right hand side of this slide. And this is called RCD frame construction. We are cast in situ. So cast in situ means you cast the concrete. Now you cast these structural elements at the site. So what you do, you put the formwork, put the reinforcement, insert the reinforcement cage, pour the concrete, then remove the formwork, allow the concrete to cure, and once it is cured, then you put the beams and you put the formwork for the slab, lay the reinforcement of slab, cast the slab, and that way you create the structure. So this is called framed structure. So framed structure is essentially RCC beam column structure. So it's a skeleton of your building, and later the walls are filled with anything. It can be brick masonry, it can be AC block, it can be fly ash block. So this is the typical construction which you will see across the world. And what we are trying to do, we are trying to, and this is also known as business as usual approach, because these two systems do exist in globally since ages, and and it has been found that these systems are not sustainable. There are time overruns, cost overruns, and there are other issues associated with these systems, so which I will explain you. So there is need to replace these systems by some innovative construction systems. Okay, and that is why the whole attempt was made through Global Housing Technology Challenge to bring these innovative systems and replace these existing systems which we have. So if we continue to use this conventional system, which I just explained you, so on left hand side you find conventional construction system service this alternate or innovative construction system. So first is slow. All of you know most of the projects, whether big projects or small projects, they are struggle with the completion. They are slow track construction, and essentially by using these innovative construction systems, you can fast track the construction process. And yesterday only we were sharing with the us that in Chennai, the project of 1,152 tenements normally takes 24 to 36 months to complete, but the project was completed in 12 months. So that is the fast delivery of houses. So you can cut down the construction time by more than 50%. So, and the moment you cut down the construction time, the advantages. Time is money, so you save a whole lot of money as well. Second is maximum use of natural resources. All of you know, I am not teaching you sustainability, but when you are using red brick or you are using cement or you are using steel, all these are the raw materials which are based on finite natural resources. And the way these materials are being used at this site, when there is no control supervision, there is a whole lot of wastage of these natural resources. Whereas when you are using these innovative construction systems, in most of these innovative construction systems, what we are doing is we are constructing, majority of construction activities are taking place in the factory or under control conditions. So naturally you bring in efficiency, productivity, and optimally use your resources. Okay, so that is why these innovative construction systems are called resource efficient systems. Waste generation, you go to any construction site, you will find heaps of construction and demolition waste here and there, heaps of sand, aggregates, and other things which lie waste, which also add to the pollution, air and water pollution. But in case when you are doing most of the construction activities in the factory or under control condition, in the casting yard, you minimize the waste. Okay, I always give the example of metro. How metro is being constructed. So those big girders of metro are being cast in the casting yards, and once they are ready to be transported to the site, you bring them to the site and just connect them. And that's how nowadays all elevated roads and highways are being made. So there is no wastage, there is no pollution, there is no interference to other normal activities. Okay. Labor intensive, all of you know, conventional construction system is labor intensive, whereas innovative construction system, like industrialized system, it doesn't mean that we don't require labor, but in the moment you make it industrialized system, there are a whole lot of other avenues for jobs and other things. So by bringing industrialized system, you bring in quality, durability, and affordability as well. Conventional construction systems are prescriptive designs. You all know that we have a wall thickness of 9 inch, we have a slab thickness of 4 to 6 inches. So these are all prescriptive design, irrespective of number of stories, irrespective of the geoclimatic condition, irrespective of the location. We always do the prescriptive design without understanding the economics of it. Whereas in innovative construction system, depending upon your zone, depending upon your geoclimatic condition, bearing capacity, and all these things, design is evolved, and then you do the design. So thereby you can reduce cost, and that is why it is called cost-effective design. Conventional construction system, you may not be knowing. Let me share with you that we are always talking about air quality index, which is external air quality. But have you ever thought of indoor air quality? Indoor air quality is also as poisonous as your outside air quality. In fact, in one of the study done by UN Environment Production Program (UNEP), it was concluded that inside air quality is 2 to 3 times more poisonous than the outside air quality. And why it has happened? Because the kind of paints, varnishes, and other chemicals we use inside our houses, which create a kind of the odor and volatile organic compounds, which creates an unhealthy environment. Whereas by employing this innovative construction system, you can ensure better health and productivity. Thermal comfort is being talked about. So through these innovative construction systems, like the system which we are using in Indore, it provides much enhanced thermal comfort and thereby increasing the productivity. So if you're living in a comfortable house or in a comfortable building, so productivity naturally increases. Okay, conventional construction systems require regular maintenance, incurring huge cost, whereas an alternate construction system or innovative construction systems require bare minimum maintenance, and thereby the life cycle cost is also minimized. Energy intensive conventional construction system, whether we talk about soil, the brick or cement and other things, they all require a whole lot of energy during their manufacturing and production, and also emit a lot of greenhouse gases, where in innovative construction systems, these are energy efficient systems. When you do the construction in casting situ, you need to have strict quality control and quality assurance plan. If you don't have that, what you have, most of the time the projects result into poor quality and poor performance. Whereas when you are doing the production, you're manufacturing, imagine making a wall in the factory and making a wall in the at the site. So once you make the wall or any structural component in the factory, naturally you are producing that under control condition, and it's an industrialized system. So naturally you can have a better control on quality. So those components are quality, offer better quality and as well as durable. And just by having energy efficient things and the other things, by optimizing resources and all, you can bring down the greenhouse gas emission. And in the context of global climate change mitigation strategies and zero carbon development being talked about, we need to reduce the greenhouse gas emissions also in the construction sector. So whether it is brick or it is cement or it is steel, all of us know that during the burning and during their production, greenhouse gases, prominently CO2 is being emitted, whereas here you can lower those greenhouse gas emissions. So in all, whatever these advantages I told you about innovative construction systems lead to sustainable construction, sustainable development, whereas conventional construction systems or business as usual approach lead to unsustainable development. And that is why it is more apt to go for innovative construction systems. This is again an acronym written for all of you, that if we use emerging construction systems, these systems will help us build safer structures. And safer is an acronym which stands with what is written in this slide. S is sustainable, A is affordable, F is functional, E is economical, and R is resilient. So sustainable, as I explained to you in the previous slide, resource efficiency, climate responsive, providing better thermal comfort and other functional parameters, environmentally responsible or environment friendly, affordable, cost effective and faster construction, functional, thermal acoustics, water tightness. Today only I was talking to one expert, and when we talk about conventional construction, there are a whole lot of problems related with water leakages and all, and so water tightness and other functional like fire performance, all these things are better when we talk about innovative construction system. They are economical in the long run because you have better quality, so low maintenance and low life cycle cost. See, nowadays we are also coining a new word called life cycle costs. So normally when we talk about a project, we are curious to know about the cost of construction. So that cost of construction is initial cost of construction. Basically, we need to account for the cost of the building during its entire service life. So that is called life cycle cost. Means life cycle cost is summation of your initial is cost of construction plus operation cost plus disposal cost. So if we want to go for sustainable development, we have to understand and we have to account for life cycle cost, because initial cost of construction is one component. There are two more costs which are associated with building, and the most important one is the operation cost, because during the service life of building, what is the cost you are incurring for its maintenance, for running that building, is also due importance if we want to have sustainable construction. So these innovative construction systems have help in low life cycle cost. Resilience. India is a country where we have multiple hazards in terms of earthquakes, floods, cyclones, landslides. So innovative construction systems offer disaster resilient structure, and they are structurally superior than your conventional construction. Also, there was a study done by the Energy Research Institute, and buildings consume most of the natural resources, most of the precious energy resource, and at the same time, emit greenhouse gases. So we need to reduce all those things, and for that, these innovative construction systems help in reduction of energy use, greenhouse gas emission, energy use, and the reduction in. Yeah, and so by employing these systems, you can reduce the energy used by 30 to 50%. Just by enhancing the thermal comfort, you can bring down the energy uses. Just by using alternate innovative construction system, you can reduce the embodied energy. Similarly, if you are using, instead of using brick wall, which requires curing and all, or typical conventional construction requiring curing and other things, that and replacing them by drywall construction, you can reduce the water use up to 40%. Then, by reducing energy and reduction in water use and other using innovative materials, you can also reduce the greenhouse gas emission, which is very important in today's context of climate. In today's, in the context of climate change mitigation and zero carbon development we are talking about. Also, the significantly waste reduction up to 75% can be achieved through this sustainability. So with this background, let me just give you those six broad categories which I talked about, and I will try to explain them pictorially. I will show you through pictures that what does it mean. So first is 3D precast concrete construction, and you can see here. So this is called 3D precast volumetric construction. So let me explain you these words. Precast means something which is not cast at the site, but it is cast somewhere else. So that somewhere else can be factory or a casting plant. So you make the entire room or entire module. So it comes with a different names. It can be the entire house, it can be a module, it can be a room, it can be a toilet, it can be a bathroom, or it can be a small project. So the entire thing comprising of 4 walls and a slab and a floor is cast somewhere else. So it is called precast. So or in a casting yard, and then brought to the site and put one over the other to create this kind of building blocks. So, and that is why it is called 3D, because instead of making these walls separately, you are making this volume. So this rectangular volume is created in the factory or in the casting yard. That is why it is called 3D precast volumetric construction. And I will show you that this technology we are using in LHP Ranchi. And when we do we already conducted a webinar in LHP Lighthouse Projects Ranchi. Next webinar, if you are able to attend, you will see to your own eyes how these 3D modules are put one over the other to create this building block. And now I think you might have understood the difference. This is the classical, conventional, traditional construction system where high-rise buildings are being made with the formwork, reinforcement, and then removing the formwork, putting the infill walls and all of that. This system is being replaced by ready-made cast pod elements or modular modules in the factory, and then being put one over the other and then jointed at the side to create the multi-story tower. So now you can understand what I'm talking about, and you know the difference. You know the advantages now. So all those things can be. Also, let me tell you, when we talk about these systems, people talk about joints and all. So let me tell you, all these joints are carefully designed through proper engineering and through proper testing and all. So all these joints are monolithic. These joints are as good as your, the conventional joints in a monolithic system. Okay, and through Global Housing Technology Challenge, we could shortlist 4 technology providers, and the project which we are doing in Ranchi, that project is being done by Magic Create Building Solutions, and this is the project. Okay. In addition to that, 3 other technology providers were shortlisted. One was Ultratech, Modocast, and Katera. Okay, and this is essentially the process of 3D volumetric construction. So what you do, you create first a mold depending upon your customized size, then you put a reinforcement cage in this in that mold, then you do the concreting, and once you do the concreting, you remove the mold, and the module is ready to be transported, and then it is transported, then it is put on our already laid foundation or already laid slab. That module is kept and then jointed through nut bolts and through wet jointing. Whole lot of jointing systems are available, and then you can put one over the other to create the multi-story buildings. So this is the Jharkhand project I am talking about, and already they have already created these 3D modules, and they are being put at the site one over the other. So this is that project at Ranchi. You can get the details of this project by visiting the GSTC website as well. Now let's move to the next category. Next category is similar to the first category. The only difference is there we were making the entire building or entire module or entire room. Here, what we are doing, we are making all the 4 walls separately. So walls, slabs, beams, columns, any structural element that is being made separately, and that is why it is called 2D. So there we are making the entire volume. Here we are making the planar element. So planar element means 2D element. So it can be facade, it can be beam, it can be column, it can be slab. So these elements are made in the factory, and this is the technology which was used in the Chennai project. So just adjacent to the project site, they set up the construction casting yard, and in that casting yard, all these beam, columns, wall panels, slabs, staircases were cast and then brought to the site and erected, assembled at site, and then through wet jointing, slab and everything was, jointed monolithically to create a monolithic structure. So this is precast concrete construction system, and it is one of the most popular technology in our country at present. So you can see here, so name any element, you can have this kind of hollow core slabs also. So just to reduce the weight of your walls and slab, you can have a hollow core slab kind of thing. So any element, wall element, solid slab element, this kind of spandrel with slab and parapet you can have staircase, you can have wall panels. So all these are being cast in the casting here. Through Global Housing Technology Challenge, 8 technology providers or 8 companies were shortlisted, and the project which was executed, completed in Chennai, Lighthouse project is done by Rcd Construction Technology Limited, and there are other agencies as well. As you can see, L&T is another one agency, Teamage is another agency. They are also quite popular and doing great work in the field of precast concrete construction systems. And all these details, if you want to get details of these companies, their emails, their contact addresses, their presentations, all these are available on the GSTC website. So you can get access to all this information through the website. And this is the project in Chennai. I showed you the picture. I showed you the small video, 30-second video also, and you can see how beautiful it looks. So 1,152 houses in 12 months were constructed using this technology. Let's move to the third category. So the first 2 categories pertain to the reinforced concrete construction, where concrete structural elements are precast, means made in the factory, manufactured in the factory or casting yard. Now here, instead of RCC, we are using steel beams and columns. Okay, so only difference is steel beam and column, and that is why it is called pre-engineered. You might have known this word pre-engineered. So pre-engineered means something which is done beforehand. It's not being done at the site, but pre-engineered. before you decide everything, decide the sizes of columns and all, and then from the factory produce those columns and beams and those elements in the factory, bring them to the sites and then erect them. You might have heard this word also being used in industrial structures. Most the industries, they are using this pre-engineered steel structural system. And now we are trying to promote this pre-engineered buildings in residential sector for housing also, because now the steel, the manufacturing of steel, the technology of steel has gone to a very advanced stage, and now we have a built-up section. So built-up sections made it possible to have any kind of rectangular, hollow, or square shape, and which makes it possible to be used for residential construction as well. So I think you understood the difference. This is typical RCC frame construction, which is being replaced. So the skeleton, remember RCC frame, I told you, beam column, those beam columns are being replaced by steel beams and columns. So these beams, you may call it girder as well. These are built up section of steel, which are produced in the factory. And then on a already laid footing, you just start erecting them, steel columns and all. And this particular pre-engineered steel structural system is being used in 3 lighthouse projects at present. Okay. So you can see this. This is how it looks like. So this what you see painted with yellow. So this is a anti-corrosive coating. So this is how these beam and columns are being erected. And then you can have this wall can be of anything. It can be sandwich panel. It can be a brick wall. It can be AC block wall. It can be AC panel. So as per your requirement, suiting to your need, you can have this kind of wall. So the idea here is, so this is called pre-engineered steel structural system. So we are replacing the RCC skeleton by this factory-made steel skeleton. There is another, we have clubbed this category with the first category which I showed is steel, pre-engineered steel structural system and light gauge steel structural system. So this light gauge steel structural system is particularly suited to 4-story structures only. So this technology is recommended only up to G+3 structure. So the difference between this and this is here you have built up sections which are not galvanized. These are heavy sections, but here and here this is a hot rolled steel. Again, understand this pre-engineered steel structural system, we are talking about hot rolled steel, and here this is called cold form steel. So cold form steel is a very lightweight steel. So you have a very thin section, and these sections are galvanized. Galvanization means they are corrosion proof. So these panels, what you see this white thing here, or gray thing here, these panels are made in the factory, and being very light in weight, they can be easily lifted by one person. So you just put these panels one over the other, one side aside each other, to create the entire wall. And in a similar fashion, you can also put them in the floor as well. So this is called light gauge, but this is recommended only up to 4 stories. Although abroad it is being used up to 8 stories, but in our country, looking at our geoclimatic profile or geoprofile, we have recommended only up to G+3 story. So in one of the lighthouse projects which we are doing in Agartala, what we are doing is we are using this steel skeleton as steel structure as the skeleton, and these walls which I told you can be dry wall, it can be brick wall. These walls are being made with this light gauge panel. So this is called light gauge panel. This is also known as cold form steel. Okay, so this is light gauge panel, or its short form is LGS, light gauge steel framing. So these panels are made with light gauge, and so the wall panels are made with light gauge, and the skeleton is made with hot rolled steel frames. Through GHTC, around 16 companies were shortlisted, and the project with light gauge, which we are doing, is being done by Mitsushimi Housing Private Limited, where they are using, as I told you, light gauge. So you can see here, this is that light gauge framing. So what you see here, this rectangular thing is a wall panel which is made in the factory, and then these panels are put together, connected together at the site to create this kind of wall. And later you can just to enclose this LGSF panel, you can put calcium silicate board, or you can put a fiber cement board, or you can put a precast concrete panel on both these sides. And the hollow space in between can be left as it is hollow, or it can be filled with any material. It can be rock wool, mineral wool, it can be lightweight concrete, or it can be a concrete of lower grade M10 or M5. Okay, just to just not to have hollowness in the structure, you can fill it with any of this material. As I told you, Agartala, this project is being done, and what you can see in the right-hand side, bottommost, this is that thing I was talking about. So that skeleton is of steel, and the wall panel is of light gauge, which you see here. So 1,000 houses in Agartala is being made with this. And, Agartala falls in seismic zone 5. And being in seismic, it is highly seismically prone. So very high damage risk zone. And there this steel structure provides, excellent earthquake resistance. And light gauge steel is lightweight. So lighter the weight, better is this seismic resistance. So this technology is quite useful and quite effective in places where we have, high damage risk due to earthquake. Let's move to the next category. This is also very popular system in our country. This is dry wall construction. So you all know how walls are being made. What you see in the left-hand side, these are the wall construction in our country. So what we do, if you are a civil engineer or architect, we normally bricklaying is done either in English bond or Flemish bond. So we make a, one brick wall or half brick wall. Then we, first soak the brick in the water. Then we put a layer of mortar. Then we put a brick, and that's how over a scaffolding and platform we create the entire wall. Then we do the plastering. How about instead of making wall like this, we get the wall made in the factory and just erect that wall or install that wall at our site. That's called dry wall construction, and there are a whole lot of options available. I will just show you through pictures. Core, depending upon their name, they are known as core EPS core panel system, which is expanded polystyrene. Expanded polystyrene is nothing but it's a thermocol of high density. And there are other kind of sandwich panel systems also. They are called sandwich panel system because there is a temperate, there is a lighter core or a softer core which is sandwiched between two facing sheets. So between two facing sheets, a lighter core, lighter weight. Lightweight core is sandwiched between two facing sheets. So that is why it is called sandwich. So let me put it in another words, means core is sandwiched between two sheets. So that is why it is called sandwich panel system. And as you can see, that facing sheet can be cement board, MGO board, or it can be irrigated concrete or concrete panel. And that inner core can be lightweight concrete, it can be irrigated concrete, or it can be EPS, expanded polystyrene core, or it can be elevated concrete, which we are using in Indore. So it can be a concrete, lightweight concrete built in between those two facing sheets. So this is that system. We are replacing this classical traditional brick wall by this customized sandwich panel system, requiring no water, and all these opening services, whether you can put them in the factory or you can put them at the side. You can create these opening at the side by easily cutting them. So you just get the entire panel made in the factory, or you can get these panels of particular sizes and then you can erect them side by side through slide and lock arrangements and just create a wall. So imagine instead of making this kind of wall, you get an entire panel, dry panel, and you just put them to create the wall. And as I told you that this is called EPS core panel system, and what you see here, this is that core. The white thing which you see is the core. This is expanded polystyrene. So it's a very lightweight, expanded polystyrene, which is a thermocol of higher density. Then what you do, this panel is sandwiched between two layers of welded wire mesh. So this is welded wire mesh, and then you do the concreting from both the sides. So that is why it is called, since the core is of EPS, so this is called EPS core panel system. And this can be of double walled, and it can be used for any structural purposes. So it can be made in a staircase, it can be converted into a slab, or it can be converted into a load bearing wall. And this EPS panel again is being recommended only up to 4 story. So if you want to go high rise, then you can use it as an anchor panel. And then you can do the shotcreting, gunite, or then you can do the plastering if you want, or otherwise you can put a simple gypsum board or fiber cement board, depending upon your requirement. Okay, so that is how these panels are being produced. And there were around 9 companies which were shortlisted, and the project which we are discussing today is being done by Rising Japan in association with KPR Projects, and this is the technology which we are using. So instead of this EPS core panel, what we are using here, wall and slash with EPS cement sandwich panel. So EPS sandwich panel system means the concrete which we are using here in the core is lightweight concrete, which is made of EPS beads, fly ash, cement. So this is also known as elevated concrete. So it's a lightweight concrete which is sandwiched between two calcium silicate boards. So in fact, I will explain you this technology in detail. So this is the technology which we are using in Indore, and Indore, the structure is G+8. So this is used as an infill wall, and the structural skeleton is of steel, which means RCC, steel beams and columns. Okay, and this EPS cement sandwich panel can also be used for load bearing application, but only up to G+1 story. So in addition to this technology, there were 8 other technology providers which are listed here. You can see Bhargav Birdhouse. Birdhouse produces EPS core panel. Bhargav produces EPS sandwich panel system. Then there is there are other host of other companies which who are into this EPS core panel systems. And this is that Indore project. Anyway, I will be discussing this in detail, and this is what I was talking about. So this is that panel which you see in the left-hand side. So this is that panel which is a EPS cement panel. So why it is called EPS cement panel? Because the core is of EPS concrete, okay, elevated concrete. Anyway, I'll explain this. So this is that panel which you can see this panel. So that core is elevated concrete, and both the sides you have calcium silicate board. Okay, and these are lightweight composite walls, and where you can see here floors and roofs sandwich panels made of thin fiber calcium silicate board on both sides, and the core is of EPS granule walls. So this is EPS beads, then cement, sand, and fly ash. Okay. Then let's move to the next category. Next is, you might be knowing, some of you, My1 system. My1 was the name of the company which started this formwork system here. Otherwise, its proper name is aluminum formwork system. Or we have given it another nomenclature, which is monolithic, because this kind of formwork produces a monolithic construction. So that is why it is called monolithic concrete construction. So here, this system is also one of the most popular system in our country right now. Most of the projects being done by developers, real estate developers, are being done with this kind of formwork system. So this formwork system is nothing but, in a typical construction of RCC frame, what you have formwork for columns, beam, and slab. So formwork, it's a formwork of steel or a plywood, which gives the form to your concrete. So if you want to create a vertical element of column, you put a formwork, rectangular formwork, and then put a reinforcement cage and do the concreting, and then remove the formwork. Okay, and then similarly for slab, and similarly for beam and slab, you put that formwork and then remove the formwork. Okay, so instead of making these beam, column, slab separately, what about making the entire building together by putting the formwork for the entire module or for the entire room together? So that is called monolithic concrete construction or aluminum formwork. So this is a customized, this is a customized formwork which is made in the factory. So depending upon your project, so first your the project requirements and the layout and the plan of your project will be considered or will be studied, and based on that, this formwork is customized and manufactured in the factory, and then this is brought to the site, and then you put the reinforcement cage and do the casting in a single pour to create all the 4 walls and slab together. So the entire room can be made in one single pour by pouring the concrete in one go, and then third day, nowadays in 3 days, you can remove this formwork and then go to the next floor. In fact, we are using this technology. There is number of variants of this technology. It comes in form of slip formwork, table formwork. There is another category, tunnel formwork, which is being used in project in LHP Rajkot. There, the entire 8 rooms, 8 houses are being cast in 3 days. So in 3 days, the entire floor is being cast, and then that formwork is being taken to the next story. Okay, and that is called tunnel formwork system. So there were there are 9 companies which were shortlisted through Global Housing Technology Challenge, and the project which I was telling you in Rajkot is being executed by Malani Construction in association with this technology provider Nord, where we are using tunnel form. Okay, and this is the project details of that project. And why we are calling it tunnel form? Because this is this kind. The earlier system which I showed you, here we are creating all the 4 walls and a slab together. But here in this tunnel form, 2 walls are being constructed. So these 2 walls, shorter walls are left open and later filled with infill walls. So through that tunnel form, why it is called tunnel form? Because you create tunnels. Okay, you create, in a typical housing project, you create a tunnel form, tunnel kind of structure, and later the shorter walls are filled with infill walls. Okay, so that is what it's called. So it is made of steel, and this is an inverted L kind of thing. So you put a reinforcement, then 2 walls and slabs are cast together, and then the outer walls, smaller walls, are filled with infill walls. So this is called model tunnel form, and is being used in LHP project at Indore. At Rajkot. Now let's move to the last category. Last category is also a kind of formwork system, but it is called stay-in-place formwork system. See, all of you might have understood by now what do I mean by formwork system. Formwork system essentially or typical means that you put the formwork to create the shape, a particular shape, whether it is beam or column, and then later that formwork is removed. Okay, and then it is removed. But what about that formwork is left in the structure, or it stays with the structure to later act as the part of the structure? Then it is called stay-in-place formwork system. So the earlier formwork is just used to give form or to give shape to your the building elements, beam or column. Here, the formwork is being used not only to give shape to the your building, wall, beam or column, but also it stays with the structure to later act as part of the structure, and that is why it is called stay-in-place formwork system. So what you see here, this is a expanded polystyrene, blocks which are being put to cast the entire wall. Then you put the concrete, and so it acts as a formwork, and then it is not removed. So it is left in the structure. So since it is a EPS blocks, so it acts as an insulation. So it provides an insulation layer to your structure. So it stays with the structure. That is why it is called a stay-in-place system. You can see a closer look. So this is how it is being put, and we are doing a project demonstration housing project in Bhopal where this technology is being used. So this comes in form of a block. So you put these blocks through slide and log and tongue and groove arrangements, create the entire wall, and do the concreting, and then later this formwork is not removed, so it acts as a part of the structure. So it stays in place formwork system. Okay, and there are 8, technology providers which were shortlisted through Global Housing Technology Challenge, and the project which we are doing in Lucknow, that is being done with the technology. This novel assembler, and this is a pre-finished wall system. Okay, so this is the stay-in-place formwork system in the general category. Here, what we are doing, we are making a ready-made walls. Okay, and these walls are pre-finished walls. So these are called PVC wall form. I will show you through the picture. Yeah. So you can see here, so this is the PVC wall form. It is being used in Lighthouse Project in Lucknow. So these walls come in different coloring options. So suppose you don't want this of white color or white color, you can have a different coloring option, red, whatever, gray color. So these walls, these hollow walls are made in the factory, and that is what is called stay-in-place PVC wall form. So this outer skin is of PVC. So this is a PVC, so that is why it is called PVC wall form, and this comes in a particular width and customized in the factory, manufactured in the factory, and the size is around 2 feet. 1 meter or 0.8 meter, and then the high length or the height of this panel can be customized depending upon the height of your size of your room, and then being this hollow, you can put the reinforcement, do the concreting. So why it is called a stay-in-place? Because this stays with the structure and also acts as a formwork, and this is pre-finished wall, so there is no need to do plaster and all. Again, this kind of building system we have recommended only up to G+3, and in Lucknow we are using high rise. So this walling system is being used with steel structural system, which I explained you earlier. Okay, so this is called PVC wall form or stay in place formwork system. And this is that project I was talking in Lucknow. So we are, what you see in the bottommost right hand portion, this is that structure skeleton I was talking about. So that skeleton is of steel, beam and columns, and then later the walls are being made with this PVC wall form. And why it is called PVC wall form? Because the skin facing sheets are of PVC. Okay. And with this, I think I have introduced you all the 6 categories very quickly, pictorially. And if you want to know more about these 6 categories, what we have done is we have created a film, audiovisual film also on these all categories. So you can just visit the YouTube channel of BMTPC, or you can go to GSTC website and have a look at those films. We have created those films in pedagogy or teaching form, so you can all understand the various intricacies of these categories. We are also working hand in hand with the state governments, and most of the state governments are now using these innovative technologies. In fact, MPs, earlier, Chhattisgarh, which was part of MP, that they started using this innovative construction. In fact, they have used precast concrete construction. One of the largest precast concrete construction project under PMAY was done in Raipur. But MP is slightly slow, but other states, they are coming forward and adopting these technologies. And, being in government, there is one of the major impediment promote these technologies, absence of schedule of road and specifications. So what we have done, we are working hand in hand with the CPWD, and for all these 54 technologies which we talked about, CPWD has already approved these technologies. They have brought out the schedule of rate also of these technologies, so that these technologies can be used by all the government departments, irrespective of their locations. And also they have come out, in fact, Ministry of Housing and Urban Affairs also, and CPWD, both of them, they have come out with the official circulars, stating that these 54 technologies essentially need to be used in the future projects of all the state governments. Okay, and under Pradhan Mantri Awas Yojana also around 16 lakh houses are being constructed using these new technologies. Also, we are working hand in hand with BIS. Apart from these lighthouse projects, we are also executing demonstration housing projects. In fact, one of the project in MP we are doing in Bhopal using this stay-in-place formwork system, which I just showed you. That picture was also from that MP project only. In Bhopal, we are using this stay-in-place where we are making 40 houses. It's a sports hostel which is being constructed using stay-in-place formwork system. So through DHP also, we are trying to disseminate these technologies so that they can be disseminated in various parts of our country. So this is the last slide through which I just wanted you all to have a look at this slide and try to understand that what we are talking about. We are talking about bringing the technology transition in the construction sector and taking all of you from level 0 to level 4 and level 3. So if you are able to understand at which level we work in our construction sector, which is level 0, and through this effort of GSTC, Lighthouse Projects, and this technology transition, we want all of us to take a jump from level 0 to level 3 and level 4. So you can see level 0 means, if I have to explain you, this is the typical construction, practice being adopted across India, where what we do, we collect the material or we procure the material at the site, mixer, aggregate, sand, cement, labor, formwork, and then do the casting, everything at the site, layout and all those things being done, and then curing and all those things are. So that is level 0, is the most primitive level. Then slowly we switched to level 1, and level 1 was somehow restricted to pre-engineered building, and pre-engineered building means, you might have seen railway station or a bus stand where, trusses are being made. So those trusses, they are made in the factory, and those trusses are then brought from the factory and assembled at the site to create the entire roof and, industrial structure. And now, so that was level 1. Then level 2 is that precast concrete construction, where you make instead of doing construction at the site, you make beam, columns, wall panels, facades, staircases, sunshades, everything in the factory, transport them at the site, assemble, erect them, join them together, and create your room or a building. That is level 0. Level 3 is another advanced stage where you make, instead of those walls and all, you make the entire room or entire module in the casting yard in the factory, and then put one over the other to create the multi-story building. And level 4 is much more advanced, which is also known as plug and play homes, where 80% of the work of your building is done in the factory. Means you create the doors, windows, finishes, everything is being done in the casting yard. So 80% of the work is done in plaster, finishes, putting the seats, platforms, almirahs, whatever, furnishing. If you want to do, everything can be done in the factory. And then the entire prepared module is brought to the site, and all you have to do is connect it with the services, water line, electricity line, and start using it. So that is level 4. And we want to, take all of you to this level 4. So level 3 and level 4. And you might be wondering, is it possible to go to level 3 and level 4? Let me tell you that already, I explained you in my presentation that already there are companies, there are technology providers in our country who are into level 3 and level 4. In fact, in the project which we are doing in Ranchi by Magically, there is another company called Home Mission. They are at level 4, where 80% of the construction work, including finishes and all, is done in the factory. So all of you can go and visit the LHP project at Ranchi and see through your own eyes that we are slowly transiting to level 3 and level 4. So with this, this is the end of the first lecture, where we have tried to give you the glimpse of all the 54 technologies. Now we will have just 5 minutes break, and after that we will give you quickly. I will tell you in detail about the technologies being used in Lighthouse project at Indore, and then we will take you to the virtual tour of the Lighthouse project at Indore. So we'll just break for, say, let's start. We'll start at 4:30. Again, I will show you another, presentation on the Lighthouse project at Indore. Okay.
अभी कनेक्ट
Sir, your voice is not coming, sir. Sir, are you on mute? Shailesh, sir.
Okay, okay, sorry. Now I,
No,
Oh,
Now,
God.
okay. Now it's coming, sir.
अरे यार मैं तो बहुत देर से बोल रहा था. Okay, so I have to start again now. चलो, I'll do it quickly. Sorry, nobody told me that my voice is not coming. So, see, let's go straight away to Lighthouse Project Indore technology being used. So, you can see here, this is the technology which is being used. What we are doing for skeleton of the building, we are using, the built-up sections which are steel built-up sections which are manufactured in the site. And for wall, we are using this innovative technology which is called cement EPS panel. Okay, and as I explained you, these are sandwich panel systems where you have two facing sheets which are calcium silicate board, and in between you have lightweight concrete. Is a special concrete, which is this special concrete is made with EPS balls, cement, fly ash. So we are not using coarse aggregate. Coarse aggregates are being replaced by EPS beads, and that is why it is called lightweight concrete. Okay, and for slab, foundation is conventional, that is RCC footing, and wherever we have staircase and lift wells, there we are using RCC shear walls. Okay, so this is that beam and column system. Then for slabs or for the floors, we are using deck slab. So deck slab essentially comprises of deck sheet. Deck sheet is a profiled steel galvanized steel sheet over which nominal with a nominal reinforcement 75 mm of concrete sheet is being done. So this slab can be can be laid pretty fast. So that kind of slab is being used here. And for walling, we are using this innovative prefabricated sandwich panel system. And this particular panel being used here is a patented technology of Rising Japan. And it is known as Rising Cement panels. And why it is called Rising Cement EPS panel? Because there is a, the core of EPS, lightweight concrete, which comprises of EPS granule walls, cement, sand, fly ash, and then this core is sandwiched between two calcium silicate boards. Okay, and then they come, as I told you, the width of this panel is around 2 feet, and the height of this is 2.44 meters. So if you have a 3 meter height, then you have to cut one panel and then put like this, and this comes in form of slide and lock arrangement. So you erect these panels one side by side to create the entire wall, and later these joints are filled with the cement slurry to create the entire wall. And there is no need to plaster and all this. This is a typical factory setup. There are two factories right now. One is in Pune and one is in Nagpur, from where these panels are being manufactured and then brought to the site. This is the typical detail of this panel. You can see the height of the panel is 2.44 meter. The width is 600 mm, and what you see this lighter core is the special concrete which I just talked to you. And thickness is 52 to 50 mm. Since it is a customized, so as per your requirement, in Indore, the thickness of panel used is 120 mm for external wall and 90 mm internal wall. Just imagine that the typical construction, we have 9 inches wall or 230 mm wall. So that wall is being replaced by relatively thin wall of better durability and a better quality the product. Okay, so and just by reducing that wall thickness, we get more carpet area or more space inside the house for the same built up area. So that is another advantage. And when we are talking about these panels, so since they are customized, so wherever you have corner, wherever you have L joints, T joints, or any corners, so those corner elements are also customized and made in the factory, and they are also being delivered to you. So at the joint, you can put those, panels of those without any difficulty. And these panels are lightweight, so they can be easily handled by 1 or 2 people manually, and you just bring them to the site, and over the already erected double bars and all, you can just put these panels side by side to each other to create the entire wall panel. Okay. And as you can see here, the thickness of the panel is 120 and 90 for interior wall. Okay, and you can see the density of this, the weight of one wall panel is 74 to 105 kg. If it is 60 mm wall, then it is 74 kg. If it is external wall, it is around 135 kg. So it can be easily handled and lifted by the person. Okay, this is just to show you the installation process. I also, the technology provider is kind enough to give me a film on how to install these panels at the site. side. So I will show you that thing. So what you have first, you have to create a frame. You might have seen. So first you have a frame. So here the frame is steel structure, which is beam and column, RCC beam and column. Okay, and then the infill walls are filled with these panels. So these are the various, stages of these panels which are being done. So these panels you put one side over the other through slide and log arrangement, and two panels are connected through these double rods at a 45 degrees, and later this space between these two can be filled with the slurry. Joints between these two panels are filled with exterior grade superfine ready mix plaster. So this is a ready mix plaster. You just need to put water into it and just grout or just fill it there, and then later you put a non-crack, anti-crack fiber tape to give it a uniform look. Okay, so I think I have a video also which I will show you, and then wherever you have T joint or L joint, so for there also you have specialized elements created, and those elements can be put at those corner elements also in the concept. So this is various stages. This is the sandwich panel system. So first you create a skeleton, then over the skeleton you put a deck slab, and this is a deck slab. Then you do concreting, and then you put this panel like this. And once this panel is being put, the building looks like this, and this, this is a deck sheet. Then we are having a false roof here, false, ceiling also. So this is a false ceiling. So these are the various stages. First you erect the structure, then you put the deck slab, and then you put this dry wall, the walling system, okay, to create the structure. And this, I will skip this slide because we are running short of time. This project is being executed by KPR project. This is the implementing agency, and technology provider is Rcd Japan. As I told you, this is the brand new technology being used at such a large scale in India for the first time. And being this, lightweight concrete, this gives excellent thermal comfort, and being light in weight, it also reduces the overall load of the building and gives you cost-effective design. This also I will skip because in the last lecture I discussed this in detail. All these projects are being awarded on a design and build basis, or EPS contracting system is being used. So there the design has to be done by the agency, and when we do the design, we have to do it comprehensively, taking into account the geo profile of the location. So like for Indore, this is the seismic zone of map. This is a wind hazard zone map of the Indore region, and you can see the Indore falls in a wind speed of high damage risk zone, which is 47 meter per second. Similarly, for earthquake, fortunately, the seismic zone is 3, which is a moderate damage risk zone. So depending upon the and all, the entire building is designed, and then that design is being approved by the ministry. Then only it can be implemented. And this is the structural analysis is done. The entire building is modeled through computer-aided design softwares, and then design is being done, and then the drawings are prepared for construction purposes. Okay, so I will not show you all these things. I will just show you through pictures to make it more interesting. So this is a typical, whenever you are doing a project of such a big project, so instead of relying on RMC or other thing, it's better to have your own batching plant. So the company, the agency has put a batching plant at the site itself. This is the batching plant, and by putting batching plant, you can actually optimize the material quantities, exact quantities of cement, aggregate, and everything can be measured and fed, and you can get the desired quality of concrete and other materials. Okay, then at each site we have also established the quality control laboratory comprising of the molds, then compression testing machine, ovens, sieve size, and all to have quality control and quality assurance. Also, for all these projects, there is a IIT Madras's third TPIMA, which is third party inspection and monitoring agency, which is monitoring all these projects as third party. So this is what typical foundation you can see. So for laying the foundation, since as I told you, we have a isolated footing. So you can see this is the reinforcement of that isolated footing being put, and wherever we have lift well or staircase well, we are making RCC shear walls. So instead of RCC isolated footing, they have shear walls because the entire core has to go. And since this, these shear walls are being put with this kind of quota stone, so as to minimize the ingress of water in these shear walls, because the chloride content in the soil are higher. So just to avoid mixed moisture content, so this is quota stone is being put over that wall. Okay, so this is that you can see here isolated footings being cast, and then once we come to the plinth level, then at plinth level you have to put a plinth beam so that all the RCC footings are connected together. Okay, and then once at the plinth level itself, wherever those steel columns are coming, you have to put those anchor bolts, and anchor bolts are put with a template. And then you have a sleeve, this kind of sleeve, and in this anchor bolts are cast, and then these anchor bolts are cast along with the this plinth beam. So these anchor bolts, and then you have since they are made with a template. So in factory, what we are making those columns, they come with a base plate, and that base plate is just put over this and then connected with nut and bolts to create the column. Okay, so you might have understood, first we have RCC footing, then RCC footing we have a plinth beam, and wherever we are coming columns, we insert these anchor bolts, and anchor bolts are cast with this plinth beam, and then over this we put the steel columns. So you can see this is the plinth beam, and this is that this also I will not show you for the details. Yeah, so you can see this. This is the typical, this also explained you. This is how it is being done. This is a steel section, and then these are the bonding sections. Okay, and that slide is not there. Deck sheet. Yeah, this slide I also wanted to show you that this is a typical section of your floor. So what you have this deck sheet. Okay, so this deck sheet is a profile sheet of steel of thickness 0.9 mm. So this sheet is put like this, and then over this deck sheet you put a nominal reinforcement, and over that nominal reinforcement you put a 75 mm concrete steel, which is of M25. Okay, and this is that deck sheet, and there you have this beam, so that over that beams, you put this deck sheet, and then you put a concrete steel for floor. So this is all because we are already running short of time, and as regards services and all, because in every lecture these questions are being asked, so you have to use special, chiseling, and for chiseling and all, like you do in your typical conventional project. Similarly, you can put any kind of services, wash basins, seats, closets, faucets, okay, platforms. Everything can be done with these with this wall panels and with this kind of system. And only thing is you have to use special equipment for chiseling and for cutting those panels. Okay, and there are other finishing items being used are press steel doors and flush shutters and all. We are also using UPVC frame for windows, vitrified tiles for all the rooms, and quota stone for common areas and all that. And as I told you, there are other infrastructure facilities also. We are using STP, that's solid waste management, compound wall, horticulture, and all those things. All the street lights are renewable resources using solar lights. And then wastewater management through wastewater recycling, and that recycled water is to be used for secondary applications like gardening and flushing purposes. So that is all. This is just a progress to show you. You can see here, this already explained you. These columns are being erected. You can see here. So once you have come to the plinth level, at the plinth level, you start erecting these columns. These columns come from the factory, and what you see, these columns are 6 meter high. So what you see here at the jointing, these are the places where your beams will come. Okay, so now you can see those beams are being put on those places. And what you see here, the complete thing is a lift core well or a staircase well. So on these spaces, you put those panels which I was talking about. So you can see here. So this is the closure look of column and beams, and then this is the deck thing I was talking about. So this deck sheet and this deck sheet is galvanized steel sheet, and over this you will put a nominal reinforcement, and then you will be concrete 75. This is how it is being done. You can see here. So this, once you have put this slab, so this is the slab and this is the skeleton, and then you start erecting these prefabricated sandwich panel system, which is a cement EPS panel system. And as I told you, these panels come of a specific width, which is 610 mm. Then you have to put them side by side through a tongue and groove and slide and lock arrangements, and those this is filled with a slurry, and so there is a SOP or standard operating procedures how to fix these panels. That and normally the workforce at the site is being trained that how these panels are being installed, and with little bit of training, these panels can be easily erected and pretty quickly. So this is again another view of Indore project. You can see now project is at advanced stage of completion. You can see even sunshades. You can see these sunshades are also of these panels only. And as I told you, these technologies amenable to all kinds of common facilities which are prevalent in the common facilities and services which are prevalent in our country, like UPVC door and frame and other kinds of things. Okay, this is for so this is another view you can see. And this is how this is the progress so far being done. The project. And this is the aerial view of the entire project. You can see. So with this, we come to the end of this session, and I will also quickly show you. There is a film of 10 minutes which shows you in a video the stop sharing. I will just very quickly show you installation, because you might be interested that how these panels are being installed. So let me again share my screen to all of you. Hmm? Okay. Yeah. Yeah. So if you are able to see able to see, you're getting the voice.
Hammer, trowel, electric circular saw, electric drill, infrared level instrument, ruler, accessories, wooden wedge, steel bar, anti-crack tape, cement mortar. Step 1. Setting light and lift the wall panels and installation accessories to the location ready for install. Step 2. Applying cement mortar. Apply drenching type Pacific cement mortar to the floor and the groove of the wall panel. Step 3. Installing wall panel. Assemble the cement mortar filled wall panels into the right position. Lever on the bottom of the wall floor with engaging trowel. Make it tight. Temporarily fixed with moving wedges. Using L-type steel bar to reinforce the wall panel and floor ceiling. Step 4. Cutting. Using an electric saw, cut to the sizes needed. Length 180 by 6 millimeter steel bars are required to enter the 45-degree angle into 2 panels. One. Correcting. Step 6. Grouting. Filling up cement mortar. Step 7. Staking anti-crack tape. 2. Step 8. Slotting and wiring. Setting lines are places needing to be set with concealed wire and switch lock. Then cut a hole with the electric saw to bring a specific wire after installation. Step 9. Installing door frame and wall frame. Reserve enough space according to the size of the door and window. Then install the wall panel.
कोई भी एग्रीमेंट प्रोसेस करेगा कि 25% जो ऊपर देता है नहीं तो बाद
Step 10. Decorating the wall surface directly by plaster, wallpaper, tiles, and other painting. If the height of the wall exceeds 5 meters and the length of the wall exceeds 8 meters, the square bar, H bar, or channel seal should be added correspondingly to strengthen the joint.
Okay. Okay, I think with this, you might have understood the installation process. Only thing is, the installation shown here was with RCC frame construction. So here we have steel. So what will you do? So you can't grout a steel doll bar in the steel. So what we do? We do the welding. So instead of grouting that wall in the RCC column or beam, we weld the to create a connection between the panel and the column and beam. We weld the steel bar with that. Okay. So with this, we come to the end of this lecture. Also, let me tell you, if you want to get more details about the technology, this is a technology of Rising Japan. So you can visit their website, RI Japan. So Rising, take RI, the first two letters from Rising, and then japaninfra.com. So Sunil, if you can write that mail ID, website rijapan infra.com to get further insights about this technology. So with this, thank you very much, dear friends. And Sunil, would you like to take them for a virtual tour to the LHP site?
Yes, sir. Yes, sir. We'll do that, sir.
Let's do that then. Let's do that.
Yes, sir.
So now you will be taken to the site, and we have installed some cameras at the site, and let's see if the site engineers are able to explain you and show you some features. Over to you, Sunil.
Tarunji, are you there at Indore site? If you are there, just explain what you want to show over there. Tarunji? Sir, I think it is maybe somebody from Indore site can explain what is happening over there and how this is being constructed, or otherwise, Salesh sir.
Who's this already we explained you. What you see here are the steel frame skeleton, and then that gray thing what you see are those panels which we just discussed. So if somebody is there on the site and can show them from the inside, or can show something which is not covered in the lecture, or if you can give participant exposure to what's happening at the site at present, that will be welcome. Otherwise, I think Sunil, you only are operating. There is no one there present.
Kasinath ji, are you there? Kasinath ji, if you are there, then please explain.
Kashinath is not there, but I think I have been listening to you right from the beginning.
Good evening,
You have
sir.
covered
Vinod Chaudhary from
right,
KKR, sir.
you have
LHP
done
Indore.
everything.
ये तो रतन सिंह जी हैं.
Hello.
ये तो रतन सिंह जी, would you like to add something? Then you can, you are welcome to add.
I think you have done a much better job than any professor can do it on the subject, to be very honest. You have
Thank you
covered
for your kind
everything
words.
very clearly and very in detail. And also, in any case, our website is available, which you have already explained to them. Any questions which anybody can ask, they can write and send an email to us. We'll respond to them immediately. As far as the project is concerned, of course, it is running little late due to various reasons, but we are trying to cover it up. And today, Rajesh is not there because he's not feeling well. So there was somebody else was supposed to be there on the site. I do not know why he's not able to listen to you. But
No,
basically, what I've noticed is that you have covered almost everything. These are the structure, steel structure, and the EPS panel is being installed. We are targeting that the project should be ready by September, October, as discussed in the last meeting, and more or less everything is as per schedule now.
Okay, okay. Thank you, sir. Thank you, Ratan Singh ji. Ratan Singh ji is a very passionate technology promoter, and he is bringing this technology to India. Sir, just can you explain them this how you are connecting these panels with these steel columns and beams? If
Yeah,
you, Girish, can
you have
explain them. Yeah, yeah,
sure, sure. You
yeah.
have shown the video, a detailed installation video, in which the first portion, if you see, we have installed in a steel structure, and we have gone up to the even three panels height. The
Okay,
basically is that the once you put the first uh, panel next to the structure, there what we do is that we insert the bar and then weld the bar with the steel. So
okay,
this becomes a absolutely one piece, and also we are using adhesive, special adhesive between the panel and the bar. So the steel structure, the panel is once I left it for overnight, it becomes absolutely one piece, and it's very difficult to remove. And as far as the floor is concerned, this is a traditional bar and cement mortar is used, as
okay,
shown in the video. So in two sides, we are using the bar and the cement, and the third and fourth side, the immediate roof as well as the side, which is connected with that steel frame, is welded with the steel rod.
okay. Wonderful, wonderful, sir. Wonderful. Thank you.
And
Thank you.
inner panels are interlinked with the bars as shown in the normal construction. That's a
Okay,
tongue and groove. And
thank
being
you,
a
sir.
tongue and groove and with it filled with the mortar, it becomes one piece.
Okay, okay, okay. So thank you.
One factor which basically people do point out about the jointing. Jointing
Yes.
problems has been coming here partly because unfortunately people do not understand this technology and they are using the U channels at the bottom. U
Okay,
channels, I would very strongly not recommend. Please don't use U channels because U channel is a obstruction between the panel and the floor. It is never allowed the panel to go inside the floor and become one piece because there's a constantly one steel sheet is in between. This
okay,
is a wrong thing. It is used earlier and even now for the office partitions. Yes, with those lightweight panels, with the aerated panels where do not have any inner strength to stand alone or take the load. For them, it is okay. I have nothing to say about them. But as far as our product, EPS cement panels with a both side with calcium silicate board, please do not use these any channels under these panels and use straight away put mortar on the floor and put the panel on this and then put insert the bar so that it becomes one piece.
okay. Thank you. Thank you, Ratan Singh ji. I think Ratan Singh ji was explaining you that normally when we do a construction with sandwich panel systems, normally, to have the alignment, proper alignment and vertical, to maintain the verticality of sandwich panel, normally a U channel is put at the bottom, at the bottom. So here with this technology, that U channel is not to be put. So we always advise that there are always, SOPs given by the technology provider when we deal with this kind of panels. So always use those SOPs. And as he explained you, it's not advisable or recommended to use that U channel, which is the standard practice for other panels. So see, each technology has its own installation procedure, and we need to stick to that. Another thing which he told you, because first time in India we are using steel skeleton with this panel. So instead of grouting, you can't grout in steel, so you can weld it. So wherever we have column, that vertical, connection between the column and the panel is done through welding steel bar into the column. So these are two important takeaways for all of you. And just to make you more confident about this technology has already been approved by CPWD as well. Okay, so with this, we come to the end of today's session. And if there are some questions, you can write in the chat box. We can take them. I find Gautam ji present there. Gautam ji, आपको कुछ बोलना है? Gautam ji, कुछ बोलना है आपको? We have more than 200 participants.
Sir, you have covered all the things there, so there is no issue.
Okay. So with this, we come to the end, and if somebody wants to ask some questions, we can take them. Otherwise, I will ask Vikas to propose vote of thanks, and after that, I request everyone to switch on their videos so that Sunil can take a group virtual photograph.
Thank you very much, sir, for your nice presentation and the whole thing that you have presented over here, sir. And it is my great privilege and pleasure to thank you all participants here today for this 8th webinar, sir, and the live feed demonstration of Indore LHP. It was organized by MHA, BMTPC, and GIZ. And you all, the participants, are all the real ambassadors of these projects, and also Witchcraft, basically. Yes, Ratan Saab had said about it. So just a brief about GIZ. GIZ and KW is having a two-arm of German federal country, and we have international corporations which are set up by the German ministries. We are dealing with technical support, and KW is dealing with the financial support systems internationally. We are having our presence in more than 120 countries, and in India we have a presence in more than 15 ministries. And altogether we have around 400 plus employees over here. And we have been working in India since last 65 years. So that is the aim that we have. In India, we have been working here from last 65 years and strongly moving towards achieving 17 SDGs. With more than 60 million euros spending per year on technical support, we strive to achieve our objective through ground implementations. So in all, we have worked with the Ministry of Power as well before, and have several policy elements with respect to thermal comfort, as rightly told by Sailesh ji as well, that we have worked on energy efficiency in residential building, and we have prepared the Eco-Niwas Samhita code, the building rating system, the replicable designs, and all. Now, all these exercises are meant a lot for the application in MHA. I would really like to thank Mr. Kuldeep Narayan, Joint Secretary and Mission Director for Housing for All, who is steering the complete project from the front. And I extend my heartfelt thanks for him for always be there whenever we need his input. And despite his all schedule, he always try to give his full time to convert these LHPs into a real knowledge platform. I would also like to thank Sri R.K. Gautamji, Director MOHUA, and his constant efforts to bringing this LHP technologies to the newer height. My special thanks goes to, yes, Sailesh ji, ED BMTPC and his team to bring these innovative technology for the first time in India, an idea of having live laboratories for field learning to students, engineers, architects, developers, and professionals. I would like to emphasize over here that please register yourself in the Technograhis as Technograhis in the GSTC website. So the numbers are growing, and you will be benefited enormously about the knowledge that we are all gathered with the conceptions of LHPs and all. I sincerely thank Mr. Manish Kumar and Sunil Kumarji, Regional Coordinator MHA, and his team for bringing this naive idea of conducting this live feed and technical webinars on LHPs. This will be continued in future on rotation basis. So participants, you will see many more construction developments happening with this kind of 1 month. And basically, you will find lots of interesting topics, which in our next webinars, in the series of webinars, when there's rotations, you will find many of the things. And finally, I would like to thank the LHP Indore team, Mr. Ratan Singh ji and his and the project partner as well, and the CSB team as well over there for the site inputs to the participants. So thank you all, and thank you participants for being patient and listen everything whatever has been told by Sri Sailesh ji, who has basically the front runner in this complete technologies program. Thank you very much, sir.
Thank you. So thank you all, and please switch on your mics so that we can take a virtual, cameras, so that we can take a virtual photograph, group photograph. Puneet, Girish, Mary, Ashok, Adarsh. Sunil, can you take?
Yeah, we are taking sir photos, and now we took one. Say cheese. Thank you very much.
Thank you. Thank you all. Yeah.